through with you this evening was do some more examples of general solutions to show you the different kinds of factorizing really that needs to take place, rather than how do you solve or how do you do a general solution. So I want to try and go through these quite quickly if it's possible for me to do so. And then I wanted to do something a little bit more difficult, a little bit more unusual with you as well, if time allows us to do so. Okay, so when they ask us to do a general solution, really what we want to be doing is looking for compound angle formulae or double angle formulae. You saw in that example that I did with you on Tuesday, it was a compound angle, so we did the reversal of the expansion and then did the general solution according to that. Otherwise, look for double angles. All right, so in this case over here, in the case of the first one, you are looking at sine 2 alpha. You know that according to your compound, to your double angle formulae, there really is only one way in which you could write that, and that would be to write it as 2 sine alpha cos alpha plus 2 sine alpha equals 0. Okay, so after you have applied a compound angle or a double angle formula, look for a method of factorizing, either highest common factor, trinomial, difference of two squares, heaven forbid, something like grouping, etc., etc. So in this case, what would we do? How would we factorize in question A? What would we do here, Matrix? How would we factorize in question 2A? Exactly. All right, we would take out a highest common factor. Okay, so we could take out 2 sine alpha. That would leave us with cos alpha plus 1 equals 0. Okay, so there would be two possible solutions here. Either sine alpha would be equal to 0, or cos alpha would be equal to -1. Okay, and then you would need to do a general solution based on both of those. Okay, so when you get to this point, this value over here, this is your ratio. Okay, so that's like your Y or your output value. Sorry, please can we mute? I'm sorry, I'm hearing somebody closing doors and making coffee and I don't know whatever else going on in the background. Thank you. That is your output value on your graph, essentially. Okay, so if you were looking at your graph, you would say to yourself, for which angle is y equal to 0? But we've got to talk about the first quadrant. Okay, we're not talking about quadrants 2, 3, or 4. So in this case over here, our PAA would be 0 degrees. We would treat 0 as positive, so we could do a solution in quadrants 1 or 2. In quadrant 1, we would end up with alpha is equal to our PAA, which is 0, plus k times 360. K is an element of the integers. Or in quadrant 2, we would say 180 minus. That's our reduction formula for the second quadrant. So 180 minus 0 is 180 plus k times 360. K is an element of the integers. And then you would have to do the same thing for where cos theta or cos alpha was equal to -1. Okay, you would have to find your PAA. Do not use the negative to find the PAA. The negative is there to tell you which quadrant to work in. So when you're finding your PAA, you'd go shift cos and you'd put in 1, not -1. Okay, so that means that your PAA would be equal to you should also get 0 degrees. Now, the fact that this is negative tells us which quadrants we should work in according to our cast diagram. Okay, so in which two quadrants is cos alpha negative? It is negative in quadrants 2 and 3. Okay, so we would have alpha would be equal to, this is now quadrant 2, 180 minus 0 plus k times 360. K is an element of the integers. Okay, so alpha would be equal to 180 plus k times 360. K is an element of the integers. All right, now I also need to do a solution in quadrant 3. Why am I not going to bother in this particular case with doing a solution in quadrant 3, matrix Y? Exactly, Lisedi. It would give me the same answer. And I'm not going to repeat myself over and over and over again because it's not necessary for me to do so. Okay, so I'm not going to worry about, normally I would, but in this case, in this particular example, I'm not going to bother with that. Okay, so there really are only two general solutions to this particular problem. This one over here and that one over there. Okay, because this over here gave us the same answer. Okay, are we all good? Are there any questions? Or can I move on to B? All good, no questions? Okay, so again, look at what you've got, get it into standard form. This gives us 2 sine squared alpha plus sine alpha minus 3 equals 0. Okay, and Konais are all happy. Okay, again, think about factorizing. Okay, this is not a binomial. This is a trinomial. So it's got to factorize into 2 brackets. Let's see if you guys can do the factors and give me your answers for sine theta or sine alpha. You guys do the brackets. Tell me what you get for sine alpha. Sine alpha is this or sine alpha is that. Let me know when you're done. Sure, Eagle, not a problem. Okay, so if you needed to use the quadratic formula, okay, you could do this. You would say sine alpha equals negative b, so that would be -1 plus or minus b squared. So b is equal to 1 squared minus 4 times 2a times c all over 2a. Okay, and then there would be 2 solutions for sine alpha. Sine alpha is whatever, or sine alpha is whatever. Okay, Eagle, so just like that. Okay, good. And Konaiza, perfect. Good job. Okay, so Inconizer, you factorized beautifully. You've said 2 sine alpha plus 3, and here sine alpha minus 1. Okay, lovely. Katleho, I see you got a hand up. What's up, Katleho?
Ma'am, I just wanted to tell everybody that if they don't understand it as sine alpha, ma'am, they can just substitute, use the K method, ma'am, and then use sine alpha
Absolutely.
as, and then it's gonna be easier, ma'am. It's gonna
100%. You are quite right. You are quite right using the K method. That is a lovely suggestion. Thank you. So what Katleho is saying here is if you say let sine alpha be equal to K, then you can work with it like this. You can say 2K squared plus K minus 3 equals 0. And then that just makes it a bit easier to factorize. So yeah, absolutely. That's what you did, Voyo. Good. Yeah. Thank you so much for reminding us about that, Katleho. 100%. That's exactly what we can do here. All right. Now, what happens when we try Masejo? Yes. The only thing you're not allowed to do is, let's say in our question, let's say we had 2 sine squared x plus sine x minus 3. Then you can't use x. As long as you use a different variable, you've got to use a different variable. Okay, Masejo? So if they're working with x in the question, you use a different letter. You just can't use x. Okay. Good stuff. All right. Now, what happens with the minus 3 over 2 matrix? What happens when we try and calculate a PAA? What happens when we try and calculate a PAA for sine alpha equals minus 3 over 2? Absolutely, it gives us an error on our calculator. It says math error. Why? Shisan, I'll tell you again. Sikatelo, it's not just negative numbers. What happens if I had sine alpha equals minus 1 over 2? Could I find a PAA then? There we go, and Kanizer, you're on the right track. So PAA, somebody else was just asking, stands for positive acute angle. Okay, it's the same as your RA or your reference angle. Okay, but we prefer positive acute angle because it reminds you to be positive and it reminds you to be acute. Zwanaka, go for it. Your hand was up.
Hi, ma'am.
Hi, Zwanaka.
Now I was going to say, because this is undefined.
It's not actually undefined. When something is undefined, it means a division by 0 has taken place. If you have a look at what Zehofatso and Nkoniza have put into the chat, they are correct in their answers over there. Okay, so because your graph has a maximum of 1 and a minimum of -1. Okay, that's why it's so important to understand the graph. Okay, absolutely 100%. So just very quickly, guys, if I draw a sine curve over here, there is your maximum of 1. There is your minimum of -1. Okay, so if this is your graph, y equals sine alpha, it is not possible for sine alpha. So if it's an error, do you leave it like that? What you have to do, iPhone, and I'm sorry I'm calling you iPhone, but I don't know your name at this point, is you write no solution. Okay. So now we're just going to solve for where sine alpha was equal to 1. Okay. All right. So now we need to find, does that make sense to everybody? Are we all good? Okay, so our PAA here would be 90. 1 is positive, so we would have alpha is equal to, in quadrant 1, it would be 90 plus K times 360 K is an element of the integers. Yes, absolutely, in Koniza, you can write NA as well if you want to. No problem. Okay, or quadrant 2. Quadrant 2 would give us the same solution as quadrant 1. Okay, because it would be 180 minus 90. So we would end up with the same answer. Okay, so I'm going to stop there and I'm not going to repeat my solutions. Okay, is everybody happy with that? Yes, good. All right, lovely. Okay. And I'm not going to worry about doing question C. I want to go on and do something else that's a little bit different here and just have some different discussions with you. But again, if you've got cos 2 alpha plus cos alpha equals 0, then write your cos 2 alpha as 2 cos squared alpha minus 1. Make a trinomial, factorize, etc., etc. You know what to do in that case, I hope by now. Katlego, you got a hand up?
Sorry, ma'am. Ma'am,
Don't say sorry. Yes.
Ma'am, can you please just explain this whole concept of 90 degrees plus K, 60 degrees? K is an element of Z, or unless I don't know what that
That's fine.
alphabet is.
No problem. Katlego, I was trying to have a discussion. I don't know if you were in our lesson on Tuesday evening, but that's what I did on Tuesday night is I tried to explain to all of you. That was where I started my lesson, and I said to all the matrics, what is a general solution? And I was trying to get ideas from you guys, because the thing is they tell you to find a general solution, but you don't even know what it is that they're trying to ask you for. So I tell you what, Katlego, what I want you to do is I want you to go back and watch the video from, were you here on Tuesday? This past Tuesday, were you in our lesson? Pardon?
Yes, ma'am. But
You were in the lesson. Okay, all right, that's fine. Let me try and explain it again to you guys just briefly before I go on and I talk about some other kinds of questions that they can give you. Okay, so let's just make a little bit of space here on the side. I don't have the same diagrams that I was using because this is obviously a different lesson that I have prepared. But anyway, just to give it another go, there would be 360. Okay, so what I was trying to explain to you the other night was this. Okay, you can look at trig graphs from two perspectives. The perspective of here, number 1 on the left, or here, number 2 on the right hand side. Okay, when we're looking at the perspective on the right hand side, we've got 0 here, 90, 180, 270, and then when we get back here to 360. So essentially, what happens when our terminal arm, let's draw it in purple, when our terminal arm swings about the origin and does a full circle, it is the equivalent in the diagram on the left-hand side of doing this. Does that make sense to you? So if K is equal to 1, you have done one full revolution. Here, K would be equal to 1. You've done one full revolution. If you were to swing around again, then K would be equal to 2. Okay, so now you've done another full revolution. So that's like you going and doing another full revolution over here. Okay, if K was equal to -1, all right, then you have changed direction. And instead of you going in a anti-clockwise direction, you are now going in this direction, like that. Then K would be equal to -1. That's the same as going back like this. Okay, back to minus 360. So K is an integer. it allows you to do a full revolution. When you have started at a particular place on your graph. Okay, so for example, if you have started over here at 30 degrees and you say that K is equal to 1, you do a full revolution of 360 degrees using this as your starting point. So in other words, when your graph does that, you now are talking about that point over there. So 360 plus 30, which should be 390. And then that would give you an additional solution for whatever it was that you were given as your ratio. In this case, maybe it was equal to a half. Does that make sense to you, Katlego? So,
Yes, ma'am. Thank you, ma'am.
so that's what you're trying to do. You have to understand the graphs together with the general solutions. To me, when you understand the graphs, everything else makes sense. And that's actually the hard part, because we actually teach you the graphs at the end, but we couldn't teach you them in the beginning because that wouldn't make any sense to you either. So it's a bit of a double-edged sword, unfortunately, when it comes to trig. But as much as possible, I will try and help you guys make those connections. Okay. All right. Let's have a look at something that is perhaps just a little bit more difficult, all right, but ties into general solutions. Okay, so let's have a look at this one. In B1, it says to us, show that. So in other words, they're asking us to prove something. That if cos theta plus 30 equals 1/2 sine theta, then tan theta equals √3/2. Okay, then it says, hence, do a general solution. All right, so how are we going to do the first part? Bearing in mind, we probably need this. Let's just bring this down with us so that it's over there and we can make it bigger if we need to. Okay. What are your ideas, guys? How would we show? What do you think we should do here in number 1? Good. Good, Mosi buddy. Yes. Yes, Katlego. Nice. Compound angle on the left. Excellent. So you guys can see here on the left-hand side, compound angles exactly, Zwanaka. You can see here, cos theta plus 30 is this over here, cos A plus B. Yeah, exactly. All right. And we might have special angles creeping in there as well. Absolutely. So what we are going to do is we are going to expand cos theta plus 30 is equal to 1/2 sine theta. So on the left-hand side, we are going to do the expansion. So we are going to write cos theta cos 30 minus sine theta sine 30, and that would be equal to 1/2 sine theta. Now, what do you think you should do, Matrix? What do you think you should do now? There we go, and Koniza, good job. You know that sine 30 is 1/2. You know that cos 30 is √3/2. Beautiful. So go and sub in. So I'm going to write this as √3/2 cos theta minus half sine theta. Okay. Good. Next step. After you've subbed in your special angles, what are we going to do now? Remember, we need to show that tan theta is root 3 over 2. Remember, tan theta is sine theta over cos theta. And what do you think you should do at this step over here? I'm dropping big hints. That's it. So Kamchelo says, let's collect like terms. Good job. Okay, so root 3 over 2 cos theta equals sine theta. Well done, Kamchelo. Okay, and now to get tan theta, we have to divide both sides by cos theta. Remember, you're allowed to do that because tan theta is sine theta divided by cos theta. So you are only allowed to divide sine theta by cos theta. You cannot divide cos theta by sine theta. Okay, because that is not an identity. Okay, so we're going to divide by cos theta on both sides. We don't have to show this. I'm just doing it for our purposes here. And that's how come we end up with tan theta over here. And that is equal to root 3 over 2. And we're all very happy. Okay, so that is often something that they expect us to do. In trig is this sort of manipulation. And now they say to us, hence. Oh, I'm going to sneeze. Sorry, guys. Excuse me. Sorry about that. Hence. So if they use the word hence, it means we have to use what we did in B1. Okay, we can't go and do something else. If it says hence or otherwise, then we can do something else. But if it says hence, we have to use what we did in B1, or they thank you for your, or they are not going to give us any marks. So hence, find the solution, the general solution for cos theta plus 30 equals 1/2 sine theta. Okay, so when it says hence, what are we working with? What are we going to do here? Exactly, Techofatso. Exactly. All right, so it means we are just going to work with the tan theta equals root 3 over 2. Okay, and then do our general solution based on that. Okay, so in part 2, we would say tan theta equals root 3 over 2. We are ready to find APAA. Okay, now, Nkoniza, you can do both. I prefer just to do K times 180. But if you want to do K times 360 for tan theta, you can. But then you've got to have the two general solutions. Okay, if you do the 180, then you can just have the one general solution. So I don't know about you, but I'm lazy. If I can write less and get away with it and get all the marks, then that's what I'm gonna do every single time. Okay, so I would go with the K times 180. That's what I'm going to do here as well. Okay, so our PAA is what, guys? Are you guys getting a PAA? Yeah, I agree. 40,89. Okay, and then we will say therefore theta equals our PAA plus K times 180. K is an element of the integers, and I'm working in quadrant number 1. There we go. Okay, so if you use K times 180, you only have to do one general solution. You don't have to do two. Okay, that is because your tan graph repeats itself every 180 degrees, so it would pick up the next general solution anyway if you change the value of K to 1, etc., etc. Okay, so that makes it nice and easy and quick to get to our answers. Everybody happy with that? All right, good job. Let's just see here. Yes, Tegofatso, you should write PAA separately. Okay, so just as I've set it out here, that's how you should be setting it out as well. Okay, Lesedi, it's not necessary. Okay, because remember, that's what I was just saying, your tan graph, that's because I've used K times 180, okay, Lesedi? If I was doing K times 360, then I'd have to work in the third quadrant. But because I'm doing K times 180, I'm going to pick up my solution in the third quadrant anyway, because my tan graph repeats itself every 180 degrees. So, for example, if we look at it from this perspective, let's say your terminal arm is now there. That's 40,89 degrees. When you do K is equal to 1, your terminal arm is going to swing around and it's going to pick up, because there's 180. It's going to pick up that solution in the third quadrant anyway. Okay. Does that make sense, Lesedi? All right, that's the joy of using K times 180 when we are working with tan theta. Okay. All right. Okay, let's go and have a look at something else. Okay. Now, what I wanted to do was go and have a look at some of the questions from here. But I have actually changed my mind. And what I'm going to do is I am going to do a question like this with you guys. Okay. What if they asked you to do a general solution and they gave you something like this? So over here, they said sine theta, and over here, they said cos 2 theta. Actually, hang on a second. Hang on a second. Let's change that, because that's an identity. Let's make it cos 3 theta. Let's do that. What would we do in a situation like this? Okay, so Eagle says 2a plus a, sure. Might end up being very long if we use a compound angle, but yes. Jude, there we go, co-ratios. That's the easiest way to do this question. Okay, is to use co-ratios. Okay. Because your angles are not the same, you cannot divide by cos 3 theta on both sides. Okay, so if we use co-ratios, what we would end up doing is this, is we would say sine theta would be equal to, okay, hang on a second, Swanaka. Okay, so KEZ, sorry, Swanaka, just 1 second, everybody else. KEZ means that K is an element of the integers? Okay, so k can be equal to 0, or k can be equal to -1, or k can be equal to 1. It depends on how we are swinging around the Cartesian plane. Okay, if k is equal to -1, then we are swinging in a clockwise direction. If k is equal to 1, we're swinging in a clockwise direction and angles are getting bigger. Okay, does that make sense?
Yes, ma'am.
Okay, Swanaka, perfect. All right, so let's go back to this. Okay, so using co-ratios, how would I rewrite this? This cos 3 theta. If I want to use these co-ratios, Jude, that you mentioned, what would I do using co-ratios? How would I rewrite the right-hand side? There we go, Jude. Well, careful, Jude. You would write it as sine. Okay, so remember when you use co-ratios, cos becomes sine and sine becomes cos. Okay, you happy with that? Katleho?
Ma'am, is that 30 or is it 3?
It's 3 theta. It's not, yeah, no, it's not 30. It's 3 theta. Okay, 3 theta.
Okay, so ma'am, how does it relate to 90 minus 30? Or is it also 3 theta?
No, it's 3 theta as well. So it's 90 degrees minus 3 theta.
Okay, ma'am. Okay, ma'am.
Okay,
I think I was asleep for a little.
It's okay, that's fine.
Yes,
Okay. So when you have a question like this matrix, what you can do is you can essentially treat the angle on the right-hand side as your PAA. So your PAA would be 90 minus 3 theta. And this is the angle that you are going to work with. Again, this is positive. So in terms of your cast diagram, you are going to be working in quadrants 1 or 2. In quadrant 1, you would write theta equals, your PAA is 90 minus 3 theta plus k times 360. K is an element of the integers. Okay, so that would come over. This would give us 4 theta equals 90 plus k times 360. K is an element of the integers, and we would divide through by 4. So theta would be equal to 22,5 plus k times 90. K is an element of the integers. Now that's a very good question. There's another way that we can look at this, and that's what I want to discuss with you. Okay, you don't divide by the sign tsechofatso. Okay, but because you were taking the sign on the one side and the sign on the other side, we're going to talk about that now. It's another way of looking at it. Okay, but give me 1 second. Let me just finish this, and then we're going to come back and we're going to discuss that. Okay. All right. So, or in quadrant 2, we would say that theta is equal to 180 minus your PAA. Let's just get rid of this. Plus k times 360. K is an element of the integers. Okay, and then again, we would have to remove our brackets, collect our like terms, blah, blah, blah. You guys know the deal. So let's just do that quickly. Oopsie. Lesego, then you've got to be careful because with 90 plus, if you're working with for this one, yeah, that would be fine. Just be careful with 90 plus because then you're in the second quadrant. Okay, and if you were to work with the cos of 90 plus whatever it was, let's call it 3 theta, then you would end up with negative sine 3 theta or whatever the case was. Okay, so just be careful with 90 plus. But yes, you can do that as well. Okay. All right, and we are nearly there. We would divide through by -2. So theta would be equal to -45. And then here, whether you write plus or minus here, they're actually not going to mind. Do you know the reason why? Okay, so here, whether you write plus or minus, you're not going to get marked down. Does that make sense to everybody why you wouldn't be marked down if I still wrote plus instead of minus? I can write minus if I want to. Yes, Hillary. So in other words, essentially, it's not going to matter whether you've got plus k times 180 or whether you've got minus k times 180, because the answers that you could get, k can change its sign. So k can be -1, k can be +1. So it would sort itself out when you picked your integer values of k. Does that make sense to you? Exactly, they're all just integers. Okay, so if you wrote minus here as well, it would be fine. If you write plus there, it's fine. You obviously have to write minus in front of the 45. Okay, but it's just because of the meaning of k and the fact that it is an integer that it wouldn't matter whether you wrote plus or minus there. Lesedi?
Hi, ma'am.
Go for it, Lesedi. Hi, Lesedi.
Ma'am, when using k times 180, do you always have one solution?
When it comes, what do you mean exactly?
With the example that we did where we had one solution where we didn't work in the third quadrant.
Okay, that's just because of
Always like that.
it was tan. That's only because it was tan theta.
Okay.
Okay, there was only
So
because it was
every
tan
time we have
theta.
tan theta, it's only one solution.
It's only one solution if you use k times 180. Or you can have two solutions if you want. So what I could do here is I could do it a different way and it would also be correct. So either you can do this, what I've shown you here, or you could do this. Okay, your PAA will still be the same. You're still working in quadrants 1 and 3. So you could say theta was equal to 40,89. This is now quadrant number 1 plus k times 360. K is an element of the integers. Or quadrant 3, k, it would be 180 plus 40,89 plus k times 360. K is an element of the integers, in which case you would end up with what? 220,89. Okay, so if you are working with multiples of 360, then you have to have two general solutions. If you are working with multiples of 180, then you only need one general solution. That is for tan theta only. Okay, not for sine theta or cos theta. For sine theta and cos theta, because the graph repeats itself every 360 degrees, you have to have two general solutions, unless, of course, they are repetitions of one another of the same answer. Does that make sense, Lucedi? Okay. All right. So, sorry, I should have done it the second way, the other way here as well. I was thinking about doing it, and then I was just sort of keen to get on to the next thing, and I didn't do it. I'm sorry. I should have showed you the alternative. Okay. All right. So now we are back to the situation over here, and then Tsegofatso asked a very interesting question. Okay, and said, can't we just divide by sine on both sides? And I said, no, you are not allowed to divide by sine theta on both sides. But what you should have seen in matric, what your teachers should have shown you when it comes to general solutions, are situations like the following. Okay, so for example, in a situation like this particular question, okay, your teacher should have shown you something like, and it's exactly the same idea. So if sine A equals sine B, that's exactly like this one over here. The sine of one angle equals the sine of a different angle. Okay, the other way that we can do this is we can say to ourselves, well, either sine A equals sine B, or we can say that sine A is equal to sine 180 minus B. Okay, because this is positive. So this would be for quadrant 1, and this would be for quadrant 2. Okay, can you see how we would end up with exactly the same answer? Okay, so this would be this one here on the left, and that would be that one there on the right. Okay, so you are not dividing by sine theta. Does that make sense to you, Tsegofatso? Okay, mind blown, I hope. I love it when you guys make these connections and you start to understand how trig actually works. It's like the best thing ever in my life. Okay, so Tsegofatso, if we can just take this one step further, I know we're kind of running out of time here, but if they said to you something like this, if they gave you sine A equals negative sine B, then what would happen? Okay, because now your ratio is negative, isn't it? So either you'd end up with sine A being equal to, this would now be quadrant 3. You'd work exactly, you'll work in the third and the fourth quadrants. Very good. So either sine A would be equal to the sine of 180 plus B, or sine A would be equal to the sine of 360 minus B. Okay, does that make sense? Okay. In which case, A would be equal to 180 plus whatever B is, plus K times 360. Okay, and here A would be equal to 360 minus B plus K times 360. Does that make sense now? Okay. So be on the lookout for those as well. So they can give you cos A equals cos B, or they can give you cos A equals negative cos B. or they can give you this could go on forever, guys. I promise you. Tan A equals tan B, or they could give you tan A equals negative tan B. Okay. Yes, it has two solutions, because sine B is negative. So there are two quadrants in which it would be negative. Okay, either quadrant 3 or in quadrant 4. And sine A equals sine B also has two solutions because there are two quadrants in which sine B is positive, quadrant 1 or quadrant 2. Okay. Wow. Yeah. I wish we had more time. I wish I could spend another 3 hours discussing general solutions with you guys and talk about all the other. This is the thing with CAPS. The syllabus is just so vast. Okay, but at least this gives you something to think about. I hope it's making sense and that it has also just extended you a little bit as well. Okay, so that if you did see stuff like this, you're going to know how to deal with it. Really, Tsechofatso, nobody showed you this. Your teachers didn't teach you this. That makes me very sad. Okay, but that's okay because you're coming to Watobe. All right, so all the stuff that they hopefully didn't show you in class, we'll hopefully be able to cover all of it here before you write those final exams. Okay. Nkaniza, which question are we talking about, my darling? The one about the right-hand side. This one? Must be that one, Nkaniza. Okay, bye, Hillary. If you guys want some more practice, here are some more questions for you. You are welcome to give those a try and just see how it goes. See, look here, you maybe try it with this one, you know, where they've given you, I mean, there's more than one way to do this. Sine theta equals sine 2 theta. You could do it the way that I showed you, this new way, or if you want to use the identity, you can do that. So that's fine. I'll go down. So it's that. Okay, and then just bear in mind, so they can also do this. So cos A equals cos B, or cos A equals negative cos B, or tan A equals tan B, or tan A equals negative tan B. What I can do, hang on 1 second, hang on, don't go, Tsechofatso, if you just wait 1 second, do you know what I can do? I can actually find this and take hang on a second here, if you guys just want to, where am I? There we go. I can actually get a screenshot of it and I can put it on here and then you've got the rules. Let me just find it for you. Come on. Just give me a second, guys. And then you can go and experiment with this and play around with it. There we go, there we go, there we go. Okay, hold on 1 second. I'm almost ready to pop it onto the screen for you. Here you go. Okay.
Bye, guys.
Okay, so here you go, Tsegofatso. Take a screenshot of that if you're interested. If you're not interested, that's also okay. And then let me just show you. And you can practice this if you want to, Tsegofatso, and anybody else. Hold on 1 second. Just tell her I can't talk to her right now. Just let me find some questions for you where this would help you. Okay, here we go. Hold on. There. Okay. You can try these. There's some questions where you could apply this thing that we were talking about. Or if you wanted to do this one, here's one more difficult question. You can try this one as well. There we go. Okay, so there are 3. Oh man, where did that go? What did I do here? There we go. There. Okay, so there are 3 questions based on these rules that you guys can play around with. Okay, Matrix.